But if you don't ask, okay, I too don't have any problems. Okay, so that will tell you something here. Okay, so you see this figure here. Okay, what will I do? Okay, yeah, right. Okay, now this is the electron gun. Let us take it the left. Okay, left side corner one. This is the electron gun. Okay, now it is collimated. The word collimator implies the one which converts into a parallel beam. Collimate, convert into a parallel beam. Okay, so that parallel beam is made to fall on the nickel crystal. After falling here, it gets reflected here. Okay, so this is incident ray and this is the reflected ray. So when you know the incident ray and the reflected ray, what could be the normal? What could be the normal? Okay, normal should be a bisector of this particular angle, bisector of this particular angle. So theta by 2 is the angle of incidence and theta by 2 is the angle of reflection. Whatever theta you got here is the summation of angle of incidence plus angle of reflection. That is the total theta that is shown over here. Okay, so this is the incident light and this is the reflected light. Instead of light, let me say electron. This is the incident beam of electrons and this is the reflected beam of electrons. So the total angle between the incidence and the reflection is theta. So when you draw a perpendicular bisector of this angle, that will be the normal. Sir, but the normal is not like that, na, sir. Yeah. If at all, if you take this hexagon as your crystal, you may not see that to be a normal. But there are some lines, okay? There are some lines. Those are crystal planes. Those are crystal planes. Okay. Now, I'll go to the right side figure. Okay. Now, you see this horizontal line over here? Okay. To which the incident beam is perpendicular. Okay. The horizontal line to which the incident beam is perpendicular. Now, that is not your crystal plane. Okay. That's only a physical surface that you see. Now, what's a crystal plane? Now, crystal plane is that plane along which the number of lattice points is very large, or you have a large lattice points in that particular line. Now, those are the lines that are drawn here. Okay. In this rectangle, you see some lines, right? Now, those lines are the lines along which you have the atoms arranged, because of which the perpendicular to it will be bisecting this perpendicular will be bisecting this angle phi. Okay, now what will I do is I'll try to draw this in front of you. Okay, I'll try to add a new slide here. Okay, right here, let me see. Okay, now I'll draw one box. Okay, let me suppose that this is your crystal. Okay, I'll try to take a little less color. Okay, right. This is my crystal, but the problem is this crystal does not have the crystal planes along its horizontal surface or vertical surface, but crystal planes are in this manner. Control C, Control V. Okay, so this is another crystal plane. Okay, so like this, Control C, Control V. Now I may have another crystal plane over here, like this. Okay, these are the set of crystal planes. Okay, now I'm making a beam of electrons to incident on it like this. Okay, now I'll take its color to be something different. Okay, this is the beam of electrons that have incident. After that, Control C, Control V. This beam got reflected. Okay, is beam got reflected. Okay, in what direction? Okay, in this direction, let me say. Okay. Okay, so this is the incident beam and this is the reflected beam, and okay, this is my total angle that I see. Okay, whatever it is. Okay, this is my total angle. Okay, which I see as theta. Okay, now when this is light is incident and reflected, you need to know that we will have a normal. Okay, because it is following right. Okay. Good. Now this is the normal to these set of planes. These set of planes. This is the normal to this set of planes. Yeah. Am I clear?
Yes, sir.
Okay. Right. Now will you please come to the Bragg's law? What is Bragg's law?
N lambda equals to 2d sine theta.
Excellent. Okay. N lambda is equal to 2d sine theta. Now what is 2d sine theta? Path difference. So what is n lambda? Okay, multiples of lambda. Why should 2d sine theta be equal to n lambda? You better actually say it as 2d sine theta is equal to m lambda. Okay. It's not n lambda is equal to 2d sine theta, but 2d sine theta is equal to n lambda is the condition. Okay, sir, అటు నుంచి ఇటు పెడితే పోయే దాంట్లో what's the difference, sir? Okay, that's physics అంతే, mathematics లో ఏం డిఫరెన్స్ లేదు, physics లో ఉంది. Okay, condition for constructive interference is that the path difference should be an integral multiple of n lambda. So what is the path difference? 2d sine theta. Okay, good. Now will somebody tell me what is theta there? Yeah, what is the theta? Okay, theta value there. What is theta?
Angle between the detector and the beam of light.
One second. Will you please tell me from your Bragg's law? I want the answer from the Bragg's law.
Sir, it is the angle made by the incident ray with the normal, like A and the normal from the slit.
Okay. Once again, repeat.
Sir, in the slit, if the slit width is A and B, if a ray A is passing through A, then the theta is the angle made from the ray A and the normal at A.
I'm talking about Bragg's law. When did you come across this Bragg's law? Okay, do you know Bragg's law? Okay, when did you come across this Bragg's law? Don't hesitate, ma. మీకు ఉందా లేదా నాకు తెలియాలి. Okay. Right, let me clarify. Okay. Did you see me drawing? Somebody please respond. Did you see me drawing? Okay. Right. This red line is the incident electron beam. it is incidenting on the crystal, nickel crystal, and getting reflected from a set of parallel planes. These are the parallel planes of what? Of the nickel crystal atoms. Okay. So this is giving you the set of parallel planes of the nickel crystal atoms. So this is the reflected electron beam. This is the reflected electron beam. Okay. Now the angle between the incident direction and the reflected direction is phi. Okay. Now this blue line is your normal. Blue line is your normal. So with respect to this blue line, will you please tell me what is the angle of incidence of the electrons? Angle of incidence of the electrons.
-90 minus theta.
Kadma. Okay, 90 minus theta is okay, acceptable, excellent. Kani, okay, I have given you this angle phi. I am saying that the angle between the first and the last red ray is phi. The total angle between the incident ray and the reflected ray is phi. So what is the angle of incidence? That's it. Okay, Mal repeat chema. 5/2, right? Intak mundu oka answer chepparu. Entandi answer?
90
There are
minus
two
theta.
answers.
90 minus theta.
Good.
90 minus.
Right? So what did you say? 90 minus theta can also be written as 5/2 as you see here, right?
Same.
Okay, right. But indaka phi, phi in your friends seminar, what is the value of phi? Follow yara. It was 50 degrees. Okay, that phi was 50 degrees. Okay, now Bragg's law lo 2D sin theta lo, theta is the angle made by the incident with the planes, with the crystal planes. Okay, please remember, in Bragg's law, theta is the angle made by the rays with the crystal planes. Okay, so that is the theta value. Now will you please tell me what is the theta value?
Angle made by the ray with crystal plane.
Good. What is it? Indak chesaru kada. Ante. Abe kada? My friend could adigina question. Okay. You have seen that 5/2 is as such equivalent to 90 minus theta. 90 minus theta. Okay. Right. So what will be the value of theta? Control C. Okay. Control V. Control V. Yeah. What will be the value of theta? That will be 90 minus 5/2 is as such equivalent to theta. Can we say that? That's it. So is your problem answered, Ma? Roll number 7?
Yes, sir.
Okay, right.
So the
Are
angle is phi, no, sir. It's not theta. Angle between the detector and the beam of light, it will be phi. It's not theta.
Okay, okay. అందుకనే చెప్పాను ఇక్కడ 5 అని రాసాను ఇగో 5. 5 is the angle between, and here you will have your detector. Detector could draw chala. ఎక్కడ పోయింది? Okay, home, and then you have your detector. Okay, right. Yeah. Yeah, you have your detector.
Yeah.
Okay. Yeah. I would like you people to go through and ask your questions again. You can start